Good afternoon, everyone. I hope my voice is clear and loud enough. Quickly answer me. Is it everything clear? My voice, my screen, is everything clear to you? So let's name the participants. JNV Kolhapur, JNV Pune, JNV Rajkot, and it's M. Gandhi. JNV Vardha is also there. Okay. So someone else has joined. JNV Rajkot, JNV Daman. Okay. So previously we were discussing the conservation of mechanical energy. That's what we were discussing. I hope the idea was clear to you. That conservation of mechanical energy, how to use the reference level, these things are clear to you. So now moving ahead, one more question that you need to do of the conservation of mechanical energy. After that, we will move ahead and we will study further power and potential energy, some things about potential energy, and we will wrap the chapter after that. So the question on your screen says, a particle is placed at point A of a frictionless track ABC. A frictionless track ABC as shown in the diagram. Again, it says it is pushed slightly towards right. For example, particle is at A, it is pushed halka sa lightly pushed right side. So it will go in this path like this. Find its speed when it reaches the point B. When it reaches the point B, we need to find its speed. That's what we need to do. The height of point A is 1 meter and height of point B is 0.5 meter from the ground. Again, as there is no friction present, so we can say that mechanical energy should remain conserved. If mechanical energy is to be conserved, then what we can write? Can you identify the situations? Like this is our initial condition. And this is our final condition. Initial and final. So after finalizing the initial and final positions, we need to apply conservation of mechanical energy. What does it say? It says kinetic energy initial plus potential energy initial. This is total mechanical energy initial is equals to kinetic energy final of the ball at B. B is our final position. What if I say they are saying that ball is pushed slightly? Slightly pushed means that its kinetic energy is 0 at point A. So what I'm saying, kinetic energy is 0 at point A. Plus potential energy is what? This is our reference level now. This is the ground, which is our reference level. Now you must ask, sir, can we choose reference level at A? I will say definitely we will choose reference level at A. We can choose reference level at A. We can choose reference level at B. It's totally up to us. If we choose at reference level at A, then potential energy at A will be 0. If we choose reference level at B, then potential energy at B will be 0. So there is no issue with that. We can choose anywhere. Okay. So choosing this one as the reference level, kinetic energy at A is 0 plus potential energy initial is mgh. M, G, and height is 1 meter. is equals to energy final. We don't know kinetic energy final, plus potential energy final is again mg, and what is h? H is 0.5. Can we solve it? If we solve it, k final is half m v square is equals to, this term is mg, and this term, can you say half mg? It will go other side and it will become mg by 2. Am I right? That 1 mg minus half mg is mg by 2. So m got cancelled, half got cancelled. So v square is equals to g. V is equals to root 10 meter per second. We have taken g as 10. You can write it as 9.8 meter per second square. So that's the other case. So we have chosen v as g as 10. So this is the simple question that we can easily solve using conservation of mechanical energy theorem. Now, I hope these things are pretty much clear to you. Now again, moving ahead. Okay. Relation between potential energy and force. This is a very good relation, and a numerical has a good chance to come from this topic. And it is also useful in electrostatics. So, first of all, we will start that we know that this is again a standard relation. We know a relation between potential energy and force. We already know potential energy and work relation. What we have learned, that delta U is equals to negative of work done. This is the case that we have learned in the recall test of yesterday's class. That change in potential energy is what? Work done by the conservative forces. Work done by the conservative forces. That's what we have learned. Now, consider a situation here. What is the situation? Assume, what are we assuming? We are assuming that motion is one dimensional. One dimensional motion means that body is moving in a straight line, and we are taking it as the x-axis. Body is moving in the x-axis, and force is also in x-axis. That's what we have assumed in this particular situation. Further, we will modify it for the three-dimensional motion. And right now, if I write, work done can be written as, negative is already present. Work done can be written as force dot displacement. Let's take the displacement as dx, because we are considering the motion in the x direction. So this is the relation. If we consider the small displacement dx, then the change in potential energy will also be small. Na? What I am saying, that like this. I am saying that a body is placed on the x-axis, is moving in this direction in the presence of force. That's what I am saying. So if we are considering a very small displacement dx, then during this small displacement, change in potential energy will also be small. So that small change in potential energy can be represented as du. Du is equals to negative of f dot dx. This is a very good relation. And again, further, if you modify it, it will become du over dx is equals to negative of F. Now, I will tell you the significance of this relation. What is the significance of this negative sign? First of all, I will tell you the significance of this negative sign. This negative sign tells us that what you call du over dx, what you call du over dx. So first point is du over dx is called as potential energy gradient. Potential energy gradient. Is it clear? What is it called? Potential energy gradient. Potential energy gradient is change in the potential energy per unit length. What is potential energy gradient? Change in potential energy per unit length. If I say potential gradient, change in potential per unit length, gradient means per unit length. That's what we have learned from this term. Again, the second important point here, the negative sign. What does it say? Potential energy du is what? Change in potential energy. Dx is what? Displacement. Potential energy decreases in the direction of conservative force. This is again a most important term that I am using. Negative sign. What is the meaning of negative sign in this relation? Potential energy decreases in the direction of conservative force. If you move in the direction of conservative force, potential energy will decrease. That's what this relation seems. For example, let's give an example on the next slide. If I say that a ball of mass m is released from certain height. This is the ground and this is the height h. Then the direction of conservative force on this ball is, you will say the direction of conservative force is mg and it is downward. So conservative force is acting in the downward direction. Fc is what? Conservative force. I can write conservative. It would be get better. So what if I say that if I release the ball, it will move in the direction of conservative force. And you all know that in the direction of conservative force, potential energy is decreasing. And you can see that because its height is decreasing. As the ball is coming down, its height is decreasing. So you can conclude that in the direction of conservative force, if the displacement is in the direction of conservative force, then the potential energy will decrease. Is it clear to you? The statement is clear to you. I hope the things are pretty much clear in your mind. Now, again, the relation we have derived here, this is for one-dimensional motion only. Now, what if the displacement is not only in x direction, it is moving some in space in 3D? Then in that case, what should I do? So I am writing here for three-dimensional motion. For three-dimensional motion. If I write in three-dimensional motion, now, listen to me very carefully. We have learned that F is equals to negative of du over dx. So, the force, if I write force, then it has three components: x direction, y direction, z direction. You have written that force is, in the previous lectures, we have seen that force can be written as Fx I cap plus force in the y direction j cap plus force in the z direction, that is represented as k cap. This is the actual format of force. And we have seen that F is equals to minus du over dx. Can you say that? Can you say that F is equals to minus du over dx? Nothing is wrong in these two statements? Both are identical. So I am writing it. If I am going to consider only x direction, then how can we write it? There is a new term. I hope that you might not have heard. Fx is equals to minus del u over del x. Don't worry, I will explain it to you. This is nothing but it is called as partial differentiation of u with respect to x. Don't worry at all. I will explain everything to you. Partial differentiation means when you are differentiating u with respect to x, that means only x is variable, nothing else is going to vary. For example, there are three dimensions, x, y, and z. When you partially differentiate something with respect to x, that means y and z are constant in that case. You will treat y and z as a constant. This is what simple meaning of partial differentiation. If I differentiate, for example, if I write force in the y direction, then what it will be? It will be negative of partial differentiation of u with respect to y. It is pronounced at del u over del y. And what is the meaning of this term? That while differentiating, you will consider x and z as a constant. In this case, you will consider y and z as constant. Similarly, if I write fz, then what it will be? It will be negative of curl u over curl del u over del z. And what is the meaning? That while you are differentiating it, x and y are constant. We will simply do it with a question. Don't worry. So net force can be written as these three values are to be put here. If you put these values there, can we take negative as a common sign outside? It will become del u over del x I cap minus del u over del y j cap, sorry, plus del u over del z k cap. This is what force in three dimensions. That's a simple term. Don't worry. What you need to remember, in three dimension, if we need to calculate force in the x direction, you need to partially differentiate it like that. You need to partially differentiate it like that. These are the simple things. Is it clear to you? I hope these things are clear to you. Again, one more thing that we will discuss here. One more formula. That I will discuss. Okay. I will discuss it here. What if you need to write the potential energy? You are given with force. You have a force given and you need to find the potential energy. What we will do in that case? Okay, what it looks like you are getting a bit confused. So let's solve a question first. After that, we will discuss the second case in 3D. Okay, don't worry. We will discuss the second case, but after a numerical so that you can get some concept here. Okay. So question on the screen is like this. Question says the potential energy of a particle is given as U is equals to kxy. This is the potential energy. Find the force acting on the particle. So you were given with potential energy and force is being asked. if I am right, the potential energy has dependency on X and Y. So forces must be in X and Y, not in Z. First thing that is very clear to me, that if potential energy has dependency on X and Y, then the force must also depend on X and Y, and there is no need of Z component. So how would you write force? Force in the X direction is written as minus del U over del X. That's what we have learned. Okay. Minus. Have you learned the differentiation? Na? Some facts are known to you about differentiation. I am assuming it. And you have to differentiate U. U is what? Kxy. Now, what I have told you, that if you are differentiating it with respect to x, then all other things are going to be constant. And you all know that constant may be taken out of the differentiation. So it can be written as minus, what are the constant? K and y are the constant. They are taken out. What is left? That's what we have left. And differentiation of x with respect to x is 1. That's, you know that. So fx, force in the x direction, becomes minus ky. Again, if I write force in the y direction, you will write it as negative of del u over del y. I will again put the value del over del y. U is what? Kxy. Can anyone answer which terms are going to be constant in this time? We are differentiating with respect to y. So k and x both are constant. This is what the meaning of partial differentiation. So if I take k and x outside, what's left behind? Partial differentiation with respect to y of y. Partial differentiation, any differentiation with respect to y of y is 1. So force in the y direction will be negative kx. We got these things. We got fx, we got fy. Now, if you write force, what is this? Fx I cap plus fy j cap. You can simply put these values. Fx I cap means fx is what? Minus ky. This is what fx I cap. Fy is what? Kx j cap. And this is your answer. Please say at least some words that is this thing clear to you? Because this thing is very important for us to know. And these things come in the exams, in the mains exam as well. So I hope this thing is very much clear to you. Please answer very quickly. I'm waiting for you. You don't have any doubt? Okay. Can we move further? Okay. So there is a next question on your screen. What's the difference in these two questions? First, have a look at the question. After that, we will discuss. Okay. Shall we start? Here, force is given. force is given and they are asking the potential energy. In the previous question, potential energy was given and they were asking the force. So things are like that. And we know a relation. This is not the part of the numerical. This is something extra we are going to do. What we have learned, du over dx is equals to negative of f. That's what we have learned. So in 3D, in 3 dimensions, we can write it as du is equals to, if we are talking about, we are dealing in 3D, then there will be a dx, there will be a dy, there will be a dz. All displacement, there will, all 3 dimensions have some displacement. Then it will be like minus fx in 3D. If you know the force, you can calculate the potential energy in this way: fx dx, fy dy, fz dz, negative of. Okay. Now let's try the question on the board. Can you see that f is given as x square I cap plus y square j cap? The term written with I cap, the term written with I cap is what? Is what? Is fx. The term written with j cap is fy. This is the basic thing that I am telling you. The term written with j cap is what? Fy, I cap is what? Fx. So you know fx and you know fy. Clear? So if I write du, it will be minus is already there in the formula. You can see the formula here. Formula is on your board. You can write it on your notebook or you can memorize it, whatever you want to do. Okay. So what it says, minus fx dx plus fy dy. We are not using z because k component or z component of force is not given to us, which is 0. So we are not using that. Okay. This is du. If I integrate it, it will become like that. Now, what are the limits of this integration? This will be delta u. Point A is 1, 1. X direction mein initial point is 1 and final point is 2. You need to, for example, if I write A and B, A is what? 1, 1. B is what? 2, 3. So in X direction, limit is from 1 to 2. 1 to 2. In Y direction, limit is from 1 to 3. And if I write here, limit is from A to B, because we are dealing A here and B in the upper limit. So A to B. Will it become UB minus UA is equals to, negative is already there. Now place the values. Fx is what? X square dx plus Fy is what? Y square dy. Limit is 1 to 3. 1 to 2. Can you all differentiate it? Can you all differentiate it? Sorry, integrate it. X square, the integration of x square is x cube by 3. X cube by 3. The integration of y square is y cube by 3. Clear? Okay, let me solve it for you. UB minus UA is equals to, negative is already there. X square differentiation is x cube by 3. Limit is 1 to 2 plus y cube by 3. Limit is 1 to 3. Now it's the simple term. If I use some basic mathematics, UB minus UA is given. They are saying potential energy at A is 10 joule. 10 is equals to. I know it's becoming a little bit calculative, but these are the things that you need to know, na? Minus is there. If I solve the upper limit minus lower limit, it will be 8 minus 1. 8 minus 1 divided by 3. That means 7 by 3. Plus sign is there. If I put 3 here, 27 minus 1, that is 26 by 3. So UB will become, this 10 will go there, 10 minus, I think this is 33 by 3. 33 by 3, that is 11, that is minus 1 joule. Is it clear to you? These two questions need to be in your mind every time. This is the most important question of the class. Now, we will move ahead. We have taken a lot of time in these two questions. Moving ahead. Power. This is the simple term. Now the simple physics has started. The power. Okay. You all know that what is power? Power is defined as rate of doing work. Again, rate of doing work is what? Rate of doing work is how quickly you can perform some work, how quickly you can do some work is what rate of doing work. For that, we have defined power in two ways. One is average power and one is instantaneous power. So we will go with both. First of all, we are mentioning average power. Average power is what? P average, it is written as either this way or someone uses the sign convention P average. Both are valid. This is not the vector sign, this is average sign, mean power, average power kind of thing. So it is defined as work done per unit time. It is defined as work done per unit time. This is a simple term. If you were asked about the units of power, then you will say work is joule, time is second, that is joule per second, and it is also known as watt, denoted by capital W. This is the unit of power. Okay. This is what average power is. Now, if I define instantaneous power. So instantaneous power is what? Power at a particular instant. For example, I'm just giving you an example. This is a block, and you are the person pulling it with some string. You are pulling it this way. If you are applying some force, that means you are investing some power, you are doing some work in displacing it, and the block is displacing in this direction. Block has the displacement in this direction. Then what I am saying, that you are doing some work. Then what is the rate of doing work is called power. But if I ask that at the instant of t equals to 4 seconds, what is the power that is being delivered by you? That means I have defined a specified moment at t equals to 4, at 4:30 and 10 seconds, at 3 seconds. This is the specific time. This is what instantaneous power. At that moment, the power delivery. So it is defined as P. This is written as simply P. P is actually P was average was W over T. This T is the time period. Now, if I say the time period for 1 second, for if I am saying that exactly at t equals to 4 seconds, that means that time is very small. That means time period is very small. So what I am going to do, I am going to apply a limit t tends to 0. What is the meaning of t tends to 0? That means t is becoming smaller, 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 and very much smaller. Does it become a moment? It will become a moment now, because t equals to 4 seconds is what? It's just a moment. W over t. As t approaches, you have learned this concept in, I hope, instantaneous velocity and instantaneous acceleration, where you have studied that. So P instantaneous will become dw over dt. P instantaneous is what? dw over dt. Now again, we can simplify it. Again, assume the force, this force F is constant. This force F is constant. Then can you write this thing? P is equals to d over dt. Work done is what? Work done can be written as force dot displacement. F dot displacement. Is it clear now? And what I'm saying, that force is constant. In that situation, if force is constant, P can be written as, force can be taken outside the differentiation, F ds over dt. What is S here? S is the displacement. And displacement ds over dt is what? Velocity. So P will become F dot V. This is again a very important relation. So we have two formulas for power. One is average power, which is work done per unit time, rate of doing work. Second is instantaneous power, P is F dot V. Remember these two formulas? So can we move ahead? Have you remembered these two formulas, two relations? These are very important. Okay. Let's do a question. Okay, so now there is a punchline. We need to get some punchlines actually. These are the important things. Huh? Okay. First punchline. Can you say power is dw over dt? Now I need your response this time. You need to answer. What if I say, what is the meaning of dy over dx? Anyone know that what is the meaning of dy over dx if I plot a graph of y versus x, something like that? Then what is the meaning of this dy over dx? Anyone know the answer? Anyone who can answer in the chat box? I am considering the answer from both Zoom and YouTube. I'm considering both the answers. If anyone can answer. Okay. 7 schools are there and nobody can answer yes, no, we know that, yes, answer anything that you can write. That what is the meaning of dy over dx? Okay. No. Nobody is saying no. Nobody is saying yes. Everyone is just neutral. Okay. This dy over dx, meaning of this dy over dx is what? Slope. Meaning of this dy over dx is what? Slope. Slope is what? At this point, slope is called the tangent. Slope is called the tangent. So what if I say that dw over dt? Dw is what? Work done. W is what? Work done. T is what? Time. So dw over dt is what? This is the slope of, again, this is basic thing. This is not the chapter related thing. This is basic fundamental physics. This is fundamental physics. You don't need to remember anything. You don't need to remember it in physics, in work, energy, power. This is fundamental. dw over dt is what? Slope of work and time graph. Clear? If I say dx over dt, then what is this dx over dt? This is slope of, sorry, dx over dt. This is slope of x versus t graph. Clear? And this slope of wt graph, work versus time graph, is equals to what? Instantaneous power. Is equals to what? Instantaneous power. So I will write slope of work time graph gives instantaneous power. The most important punchline. This is the simple numerical. Directly, you will get the work time graph, and you were asked about the potential, asked about the power delivered. So what you need to do? You just need to calculate the slope. Slope is what? Slope is what? Do you know further? Slope is what? Tan theta. If this angle is theta, then slope is what? Tan theta. This was the first thing. Second thing. Second thing. Again, notice this term. P is equals to dw over dt. If I transfer things, p dt is equals to dw. If you integrate it, this is again the fundamental thing that I have told you many times. P dt, integration of p dt means area under power time graph. Area under power time graph gives what? Work done. So the second important point is area under power time graph gives work done. Again, this thing is done. Now, with which axis you are going to consider the area? This is mentioned here with the time axis. With the time axis. So I hope these two punchlines are very much clear to you. Again, moving further. Now we have some questions, I think. Okay. You have a question on your screen. At least few of you should answer. Okay. What the question says? The question says an elevator of mass m with a person of mass m is moving upward with uniform velocity v. Okay. So there is an elevator. Elevator is what? Lift. This is an elevator. This elevator has a mass m and a person of mass m is small m. And this lift is moving upward with a constant velocity v. That's what we have learned. Anyone has seen the lift, how lift moves up and down? If anyone has noticed, then there is a rope attached to the elevator, attached to the lift, and this rope pulls the elevator up and down. I think you know about that, na? So if I say, and there must be a pulley, there is a pulley at the outer end of the elevator. So this lift is being pulled, and if it is being pulled, then there must be a tension in the string. There must be a tension in the string. So can you say that in lifting the elevator upward, this tension has to do some work. Work is done by this tension force, and which is being applied due to the motor of the elevator. Okay. So what I'm saying, power delivered is what? F dot V. Now, some of you might ask that why are you using instantaneous power? This is a very good question if you are asking it. If you are not asking it, then you are not up to the mark. Your study pattern is not good. The question is, why am I using instantaneous power? Rather, they just don't ask me to answer in instantaneous power. They are not asking the instantaneous power. They are just asking the power delivered by the elevator. Now, my answer is, if the velocity of the particle, velocity of the body is not changing, then at every instant, its power is going to be constant. If at every instant its power is going to be constant, then its average power will also be the same. Na? Take an example. If you are moving with constant speed of 10 meter per second, completely constant, neither becoming 9, neither becoming 11, it's exactly 10 meter per second. You are going from your home to the classroom to the school, and your speed is just 10 meter per second. Then if someone asks you what is your average speed, you will say 10 meter per second, because it's just constant everywhere. So that's what the case. Power is constant at every instant, and if power is constant, then average power will also be the same. So what I'm saying, we need to calculate this force, and who is applying force to lift the elevator is the tension, and the angle between tension and velocity, tension is upward, velocity is upward, angle is 0, so it will become T into V. So now my task is to calculate T. To calculate T, have you studied Newton laws of motion? According to that, The total mass of the lift plus man is m plus m, and the weight of this system is m plus m into g. And there is no acceleration in the y direction. There is no acceleration in the y direction because velocity is constant. So can you say that T is equals to this upward force must be equals to downward force because net force must be 0. So T is equals to m plus m into g. This is what we got. We will place the value. Power is equals to m plus m g into v. This is our answer. This is the simplest question that we can get. I hope things are clear to you. Okay, moving ahead with again another question. This is your homework that you need to do. This is the same question as I have told you previously in the previous slide. So this question you need to solve in your homework. Moving further. This is a good question. Question says, a block of mass 2 kg is pulled up on a smooth incline of angle 30 degree with the horizontal. Okay, so let's not study the question in one flow. You need to draw something from the question. So what I have got mass 2 kg block is pulled up on a smooth inclined of angle 30 degree. So first of all, I will draw an inclined plane of inclination 30 degree and I will put a mass 2 kg on it. Let's do it. I will draw an inclined plane of inclination 30 degree and I will put a block of mass 2 kg on it. Two kg on it. Then after that, I will study further. It is being pulled. Pulled means there is a force F. Now, if I study it again, the block moves with an acceleration of 1 meter per second square. This block has an acceleration of 1 meter per second square in this direction. Find the power delivered by the pulling force at a time t equals to 4 seconds. Sorry. So they are asking about the power at a particular instant t equals to 4 seconds. So if I say first part, they are asking the instantaneous power at t equals to 4 seconds. They have given me a particular time, that means they are asking me the instantaneous power. So what is the instantaneous power? P is equals to force into velocity. What you need to do, you need to calculate the velocity at t equals to 4. You need to calculate the velocity at t equals to 4. That's what you need to do. Clear? Okay. Can I say that power is F into V. This force is in this direction upward. Velocity will also be in this direction. So the angle will be 0 and it will become F into V. The vector sign will eliminate. Now, we don't know both of these parameters. Neither we were given force nor we know about the velocity. So we need to calculate these things. We need to calculate these things. Now come here. In this part, I will solve velocity. Clear? Can you see that in this direction, there will be a component of mg, that is mg sin minus mg sin theta is equals to mass into acceleration. F minus mass is 2, g is 10, and sin theta, sin 30 is what? 1 by 2 is equals to mass is what? 1 kg, sorry, 2 kg, and acceleration is what? 1 meter per second square. This 2 got cancelled and we got F is equals to 10 plus 2, 12 Newton. This is the first thing, the first unknown that we need to know is F. We got that. Second unknown that we need to know is the velocity at t equals to 4 seconds. Do you know the kinematic equation? V is equals to U plus AT. So V is equals to 0 plus A is 1, time is 4. So V is equals to 4 meter per second. Now I know both the parameters. So the power will be F is 12, velocity is 4, that is 48 watt. Is this question clear to you? Now, for the second question says, what is the average power delivered during the 4 seconds after the motion starts? Means from here till the 4 seconds. Now during the 4 seconds means they are asking average power. And what is average power? P average is equals to work done over time. Ask yourself a question that why we are not using the previous case that we have used. We have used na P equals to F dot V in the previous question, and I have told you power is constant. Then why we are not using this time? Ask yourself, and then you will answer. You will be able to answer the question. Now, okay. Do you know that time is given as 4 seconds? But we need to calculate the work done. So work done is what? Force into displacement over time. Everything clear to you? Force into displacement over time. We know the force. We know the force 12 Newton. We know the time 4 seconds. What we need to do? We need to calculate the displacement. This is very simple. You know the acceleration. You know the time. Can you calculate the displacement? Yes, you can using kinematics. Displacement is what? S is equals to ut plus half at square. ut is what? 0. Initially it was at rest. Half. A is what? 1. T square is what? 16. T square is 16 from where? Time is 4 seconds. Square, it will become 16. So displacement is 8 meter. Put that displacement and all the values, you will get force is 12 Newton, displacement is 8 meter, time is 4 seconds. So that will be 24 watt. Two answers are in front of you. Is this question clear to you? It will clear a lot of concerns, lot of doubts from your mind. This is the end of the chapter, I can say. There is one more question on your screen. And actually things are over, so you can do it in homework. This is again a very simple question. I need your answers over there. And I hope from my side, the chapter is over. We will start rotation from the next class and hope you enjoy the class. Thank you. Ending the class.